Okay, last question. They give you the angle 1 is 30 degrees. They give you angle 2 is 53 degrees. And they want to know all the tensions.
Stephanie Bapola to the main office, please. Stephanie Bapola to the main office.
Again, they tell you the mass of the block. And so you know that T3 is equal to the weight of that block, which is 15 times 10. So 150. And that is where they got T3 from. Again, you're going to do the sum of the forces in the x direction and the sum of the forces in the y direction and add them together. So make sure that you draw your axes in. T3 is down, T1 is up, T2 is up. And you are going to split them up into x's and y's. So in the x direction, you have negative T1x plus T2x equals 0. So T1, and remember this is 30, so this is also 30, times the cosine of 30 equals T2 times the cosine of 53. Two unknowns. So let's go to the y direction. In the y direction, you have T1y plus T2y minus T3 equals 0. T1 cosine of 30, or sorry, sine of 30 plus T2 sine of 53 minus 150 equals 0.
Nick Peterson, Allison Simpkins, Bailey Lynch to the main office, please. Nick Peterson, Allison Simpkins to the main office, please.
We're going to solve for T1 this time so that we can use it to plug into the other equation. And when I do the cosine of 53 divided by the cosine of 30, you get T1 equals 0.695 T2. And then you're going to plug that in up here. So now we have some math to do in our calculator. 0.347 T2 plus the sine of 53 is 0.799 T2 minus 150 equals 0. You can combine T2s. You get 1.15 T2 equals 150. Solve for T2. And you get T2 equals 131 newtons. Now you plug that in right here and solve for T1. And you get T1 equals 91 newtons. Again, they're a little bit different than us because they use 9.8 for G.